Hi, good morning, students. In the previous class we learned about the math chapters, and now we are going to learn the chapter from physics, that is electricity. Okay. So now in electricity, we are using this electricity word oftenly, and many times we'll use current. Okay. So now, what is the difference between current and what is electricity? And similarly, in this chapter, we are going to learn how electricity is produced and how electric charges are flowing through the conductor and what are its use. We are going to learn in this chapter. And apart from that, we are going to learn what is meant by potential difference and what is meant by Joule's law of heating, Ohm's law, so etc. We are learning in this chapter, and also based on these laws we have some problems. So by using that formulas and by using that definition we have to solve. And in electricity, so first if you consider one atom, centrally it is having a positive, that is central nucleus, and all the electrons are revolving around the nucleus. So you will learn this in chemistry classes. And so it has many shells, for example K element shells, and in each shells the electrons are revolving around the nucleus. So now if we consider two shells, for example in this example I will consider two shells, and the shells are arranged based on the formulas, and for example 2n square. And if I consider the electron is revolving in the second orbit or second shell, and if I consider here another electron revolving in the first orbit, then so here we know that the nucleus attracts the electrons towards it, and why we are using the negative sign. So here I wrote here E, and above I wrote minus, because so E is to represent the electron, and minus because charge of the electron is negative. Here we are considering that. And so here when you consider these two, so then force of attraction on the first shell electrons are large when you compare that with the second shell. Here force of attraction, for example if I consider for example 50 Newton, this is for example, not exactly. 50 Newton is the force of attraction on the electron. But when we consider on this electron, the force of attraction reduces. I will consider this as 20 Newton. So here N is represent Newton, and these values are imaginary values. So on the first electron, the force of attraction is 50 Newton, for example, and on the second electron it becomes 20 Newton. So that means force of attraction in the second electron is less. So that helps in the electricity process. And here, when we go to the upper shells, the force of attraction goes on decreases. So that means the electron can easily move to one orbit to another orbit, or one molecule or one atom to another atom. So that means by neighboring atoms, the electrons jump, and that process helps in the production of the electricity. Okay. So about shells and orbits, atoms, molecules you learned in chemistry, and you know very well how the electrons are bound to the nucleus. And in this electricity chapter, we need only the outermost electron. Outermost means the electron which is at the last shell. We need that, and based on that, we have two properties of electricity. One is static electricity. One is static electricity, and second one is, first one is static electricity, And the second one is current electricity. So first step, so electricity, what is meant by electricity? So electricity means it is flow of the electron. Electricity means it is flow of the electron. Flow of the electron. How the electron flows? Why it flows? So everything we will learn in this chapter. Okay. So first I will tell you this definition, flow of electron. This is a simple definition for your understanding. So actual definition is little bit bigger. So electricity, flow of the electron. So actual definition is the electricity means the rate of flow of electrons in a particular direction. That is simple. The rate of flow. So that means how much electrons are moving at a particular time. Definition I will write here, rate of flow of electron in a particular time. So rate means here for a particular time. Flow of electron, how much electrons are flowing in a particular time. If you consider unit time, or if you consider for example 10 seconds or 30 seconds, then what we have to do, we have to find out what is the electrons, how much electrons are flowing from one point to another point at that particular time. And here, so this one is very important, in a particular direction, For example, if we consider a box, or if we consider a conductor, so then the electrons are, I will represent this dot, and so they are representing the electrons. Okay, so these are electrons. I will name this as E minus. Now, one electron is moving in the left direction, another electron is moving in the downward direction, another in the upward direction, another in the right direction. So the electrons are moving in random direction. Wherever they want, they are moving. So this does not constitute current, or this does not constitute electricity, because here there is no particular directions are present. So for that we need particular direction. For the production of electricity, first one we need the outermost electron, and when it moving in a particular direction, then only electricity is produced. So therefore the definition of electricity is the rate of flow of electron in a particular direction. Rate of flow of electron in a particular direction. And electricity is a branch of physics that studies the flow of the electron. Or directly we can consider it is the electricity is a branch of physics which studies about the electron, or a movement of the electron, or properties of the electron. And here rate means for a particular time. So in this case they are moving in a random direction, and all the charges will get nullified. Because if for example we have plus 5 one term and then this minus, when we add these two terms, because all the electrons are having same charge, and when one is in positive direction, another is having negative direction. That means, for example, I will consider one electron is moving in left direction, another electron is moving in the right direction. Then what it happens? Same magnitude but different in direction. So therefore the charges will get cancelled. That produce electricity will be very less. It is a fraction, or sometimes it will not produce anything. So therefore what we need is the electron must flow in a particular direction. For example, if we consider 2 points, one is point A, one is point B, then the electron must move from A to B, or the electron must move from B to A. So in these two cases we will get the electricity, or we can produce electricity in this way. But when it moves in, when the electrons are moving the random direction, we can't produce electricity, or produce electricity will be very very less. So that can be used. And nowadays we are using in everywhere electricity. Okay, and so that based on this movement of the electron. And in this electricity chapter we have two parts. One is static electricity and one is current electricity. What is meant by static electricity? What is meant by static electricity? Static means it is constant. It does not move. That when the electrons are not moving. So static, constant electricity. So that means, for example, in the earlier classes you learned about by rubbing a plastic scale, and when we take that scale or that plastic scale near to the small piece of paper, it will attract. So that means when we rub that, so it will produce the charges. The charges will activate, and so it attracts the other particles, small particles. Okay, so that is comes under static electricity. Okay, the produced electricity due to the static electrons. And next one is current electricity. So this is very very important, and we are going to learn about this in this chapter. That is current electron. Current means when the electrons are in moving position. When the electrons are in the moving position, then we are getting the current electricity. That means when the charges are flowing from one direction to another direction. Based on the time, we are calculating the electricity, and that is known as current electricity. Current means when the electrons are in the moving position, and static means when the electrons are in the rest position, or that is the simple word, that is rest position. Okay, so one is rest electricity and one is moving electricity. Okay, and we have three terms. Apart from this, we have three terms. They are conductors, insulators, and semiconductors. Okay, so one is conductor, so this is not bus conductor. Okay, the conductor, it allows the electron to flow from one point to another point. So the conductors, this helps to move the electrons from one point to another. And next one is insulators. Okay, second one, insulator. So it does not allow the light or current to pass through. So conductor means it allows the electric charge to flow from one point to another point, and insulator means it does not. And the third one is semiconductor. So now tell me what is meant by semiconductor. Just comment me fast. So what is meant by semiconductor? So what is meant by semiconductor? So your conductor means it allows the heat or light to pass through, and insulator means it does not allow the charges to flow from one point to another, because there is one term, that is band gap. Okay, there is one term, that is band gap. We will learn about that in the further classes, and that obstructs the charges to flow from one point to another point. And now, based on this, we have very very important concept, that is electricity, how to produce electricity, what are the components of the electricity, and which units we are used to represent electricity, and what is meant by charge, and the magnitude of the charge we are going to learn. So open page number 94 in our science textbook, page number 94, electricity, that is chapter 12. So in the first line it is given that if a net charge Q flows across any cross section of a conductor in time t, then the current I through the cross section is I equals to Q by T. That means, so here we consider Q is the charge and T is the time. Okay. Here Q is the charge. And now when we consider Q as the charge and T as the time, that means the charges, Q number of charges are flowing from one end to another end in a particular time t. And in this case, we'll have another term that is I. So we represent the charge by using capital Q and time by small t and current by I. So how to relate these three terms? How to relate charge, time and current? So earlier I told you that the electricity means it is orderly flow of electron in a particular direction at a particular time, or in other words it is rate of change of electrons or rate of change of moving of the electrons in a particular direction. That is important. Particular direction is important and rate, that means time. So therefore we can give a relation for this term, that is I is equals to Q divided by T. I equals to Q divided by T, that is total number of charge flowing in a particular direction in a particular time. So T is in the denominator and that represents per time. So I is equals to Q by T. This is very, very important relationship. So how to find out the current, or how to find out the electricity, or how to find out the amount of electricity by using the number of charge flowing and by using the time taken to move. So therefore it is an orderly or rate of flow of electron in a particular direction that represents the current, and the expression for a current is I is equals to Q by T, when Q is the total number of charge flowing in a particular direction and T is the time taken for it, then I is the symbol used to represent amount of current produced in the circuit. Now in the second paragraph they give the SI units. Okay, the SI units. So SI unit of electric charge is coulomb. So charge SI unit COULOMB, coulomb, and it is represented by using capitals. So you have to remember this, very, very important. So here all the letters are small letters, and here this is capital C, and that is used to represent the charge. Okay, for example, if you consider meter, in simply what we write, we use small m. So just like the small m, here capital C, it is known as coulomb. And here C is used to represent the charge. So you have to remember one thing, why it is small c and why there it is capital C. And similarly I will tell you, so you learned about the force, and SI of the force is Newton, or you will represent that by using capital letter N. So Newton, so NEWTON or capital letter N. Why? Because these are the names of scientists who found this, who discovered these terms, and they gave their own names, and for that the first letter is small. Otherwise, for example, if you want to represent or if you want to write the name of a particular person and his name is Newton, then what do you write? You write NEWTON. But to represent the SI units of that particular terms, we use the first letter as small, and or we can consider directly capital letter. Okay, short form we have to use capital letter, and for the long form you have to use small letter. So this is applicable only for if the SI unit is name of the scientist. SI unit is name of the scientist. Then only you have to use this. So now the SI unit of charge is coulomb, or it is represented by using capital letters. And then next, time. So now what is the SI unit of time? Comment me fast. What is the SI unit of time? Comment me fast with the capital letters or small letters. Okay. So what is the exact method of representing the SI unit of time? So comment me fast. First, commenting with the SI unit of time. So some gave this comment CO and D, some gave SC, CO and D, and another option, for example, this is option A, this is option B, and third option is SE, CO and D, S, and fourth option, option D is SE, CO and D, S. So in this four option, which is the correct answer for SI unit of time? So first one is capital S and all the letters are small. In the second case, all the letters are small. In the third case, all the letters are small, and in front of that we have an S. And in the fourth case, first letter is capital, and also we have the last letter as S. So in this fourth case, which is the exact representation of SI of time? So generally we are using many SI units for time, but for example, we'll use millisecond. Okay, millisecond we'll use. So that is represented by using the ms, small and smallest. Millisecond. That means 10 raised to minus 3. So sometimes we'll use microsecond. So the micro means 10 raised to minus 6. So now comment me what is the represent or how to represent the time, or what is the SI unit of time. In this four option, choose the correct one. Some are giving B as the answer. So B is the correct answer. Yes, answer is correct. That is B. The second, all the letters are small, no in S or no capitals. So SI unit of time is second. And or, so we can write directly second, or we are write small letter S. That is the SI unit of second. And then the current. What is the SI unit of current? So current means ampere or capital letter. So ampere, okay, ampere or capital letter A. So that is the SI unit of current. And what is meant by SI? SI means international standards of unit. International standards of units. And based on that, the SI unit of charge is coulomb, or that is represented by using capital C. And SI unit of time is second, that is represented by using small letter s. And the next one is SI unit of current is ampere, and that is represented with the help of capital letter A. So now we will come to this expression, that is I equals to Q divided by T. So that is total number of electrons flowing in a particular direction with a unit time. So based on these SI units, when we want to represent, so it becomes ampere, because SI unit of current is ampere. So that's why I will use capital A, that is equals to charge. The total flow of charge is capital C divided by total time taken. Time taken is as small s. So ampere is equals to coulomb divided by time. That is coulomb divided by second. Then one question arises: what is meant by 1 ampere? What is meant by 1 ampere? So if you consider 1, there are many possibilities to get 1. For example, we can write 1 divided by 1, or we can write 3 divided by 3, or we can represent 2 divided by 2. Like that, we can continue, or we can consider the negative terms, minus 4 divided by minus 4. In all this case, we are getting 1 as the answer. And similarly, so what is meant by 1 ampere? So when we use here 1, then what it becomes? So I will consider 1 because generally we are using unit. So unit term, that means single term, or 1 in simple. Now we have to write what is meant by ampere. 1 ampere. What is meant by 1 ampere? Define 1 ampere of current. Define 1 ampere of current. 1 ampere means 1 coulomb per 1 second. That means, so actual definition is the rate of flow of current in a particular direction, or number of electrons are flowing in a particular time. So that gives the current. Now what is meant by 1 ampere? 1 ampere means we have to consider the total number of charge as 1 unit and total number of time taken is 1 second. So when 1 coulomb of charge is flowing in a particular direction in a unit second, then it produces 1 ampere of current. Okay, so listen carefully. When 1 coulomb of charge is flowing in a particular direction, so we have to use that definition, and we have to change in the charge place. We have to use 1 coulomb of charge, and in the time place we have to use 1 second, and in the current place we have to consider 1 ampere of current. So we have to give the prefix for it. So 1 ampere means when 1 coulomb of charge is flowing in a particular direction in a unit time. So 1 ampere means 1 coulomb of charge is flowing in a particular direction in a unit time. When, or directly I will write 1 ampere means when 1 coulomb of charge is flowing in a particular direction, in a unit time, in a unit time. Okay, 1 ampere means when 1 coulomb of charge is flowing in a particular direction in a unit second. Okay, unit second means single second or 1 second. So that constitutes 1 ampere. Correct. Just read that definition once again. So what is meant by 1 coulomb of charge? So when 1 ampere of current. So when 1 coulomb of charge is flowing in a particular direction with a unit time, that gives the total produced current as 1 ampere. So then here in the second paragraph they give the SI unit of electric charge is coulomb, which is equivalent to the charge contained by nearly 6 into 10 raised to 18 electrons. Okay, SI unit of charge is coulomb, which is equivalent to, that means which is equivalent to means 1 coulomb is equivalent. Okay, that is equivalent to 6 into 10 raised to 18 electrons. 1 coulomb. So I will directly use, instead of writing the whole term, I will directly use 1 capital. That is equals to, or that is equals to 6 into 10 raised to 18 electrons. 6 into 10 raised to 18. So for example, if you consider 10 raised to 1, that means 10. 10 raised to 2 means 100. So 10 raised to 3 means 1000. So see here, 10 raised to 3 means 1000. Totally 3, that means 3 0, 2, that means 2 0, 1, that means 1 0. So 10 raised to 18 means we should, in front of 1 we have to put 18 zeros. So into 6, that number of electrons gives 1 coulomb of charge. Therefore 1 coulomb of charge means it is equivalent to 6 into 10 raised to 18 electrons. That is equivalent to 6 into 10 raised to 18. So here they not give exactly equal to, they give equivalent to, that means nearly same. And next one, we know that an electron possesses a negative charge of 1.6 into 10 raised to minus 19 coulomb. The charge of the electron. Next one is charge of the electron. Charge of the electron, that is equals to 1.6, or we can write 1.602 into 10 raised to minus 19 coulomb. 1.602 into 10 raised to minus 19 coulomb, or simply we can write, or directly for the help of the calculation part, we will directly use 1.6 into 10 raised to minus 19. Okay, exactly is 1.602. So after that there are some terms into 10 raised to minus 19 coulomb, or simply we can use 1.6 into 10 raised to minus 19 coulomb. So that is the charge of the electron. So each electron consists of 1.6 into 10 raised to minus 19 coulomb of charge. The electric current is expressed by unit called ampere. We learned this, or that is represented by using capital letter A, named after the French scientist. So named after the French scientist Henri Marie Ampere. So he lived between 1775 to 1836. 1 ampere is constituted by the flow of 1 coulomb of charge per second. That is 1 ampere equals to 1 coulomb divided by 1 second. And sometimes it is represented by using the milliampere. Milli means 10 raised to minus 3 ampere. Okay, so that is given in the next one. And now we will learn some simple circuit, or before going to represent the circuit, we will go to the total components present in the electricity, and which components we can use in this part we will learn. So that is given in page number 97. Page number 97, table 12.1. Page number 97, open page number 97, table 12.1. So up to now we learned about the electricity. So electricity means it is the orderly or the rate of flow of electron in a particular direction. Rate of flow of electron in a particular direction. Or in other words, we can use the number of electrons are flowing in a particular direction with a unit time. So if we use rate, then no need to use time, or if we not use the rate word, then you have to use the time for a particular time. And after that, static electricity, the electricity is produced due to the rest electron. And current electricity, the electricity produced by using the moving electron. So the production, for the production of the electricity, so what we are using, the electron, the outermost electron, or we can call it as valence electron. So it is in the outermost shell, and the force of attraction by the nucleus is very less on that electron. So force of attraction on that electron, that means valence electron, that is very less when we compare that with the bound electrons. Okay, so electricity is the orderly flow of electron in a particular direction, and static electricity, it is the produce electricity by using the rest electrons, and that is the electricity produced due to the rest electron. And for the production of electricity, we need the valence electron, that is valence means the electron which is present in the outermost shell, or that is not paired electrons. So that one we have to consider. And so SI unit of charge is coulomb, and that coulomb means that is equals to, or we can represent it by using capital letter C, or COULOMB, and 1 coulomb, that is equals to 6 into 10 raised to 18, 6 into 10 raised to, that is equivalent to 6 into 10 raised to 18 electrons, and each electron is having charge, and that charge is equals to 1.602 into 10 raised to minus 19 coulomb, or we can represent it by using 1.6 into 10 raised to minus 19 coulomb. And we have another term, that is time, and the time is used represent by using second, or it is used or the short form of that is small letter s. And apart from that, we have one relationship, that is I is equals to Q divided by T, that is current equals to charge divided by second. That means total number of charges are flowing in a particular direction with the unit time. And next one, what is meant by 1 ampere of current? So when 1 ampere of current means when 1 coulomb of charge is flowing, when 1 coulomb of charge is flowing in a particular direction with a unit time. When 1 coulomb of charge is flowing in a particular direction in a unit time, that is that is known as 1 ampere. Okay, and in the page number 12.1, so they gave different components and their symbols. Okay, how to represent the components in the circuits. So circuit consists of battery and plug key and bulbs, and then ammeter, voltmeter, etc. for the experimental part, and for also for the representation of the when the resistors. So that comes in the later part. Resistors, when they are connected in series, or when they are connected in parallel, or in many other cases we are going to learn, or we have to draw the diagrams for that. So in that case it is helpful. So in that, the first one is electric cell. Okay, electric cell. How to represent electric cell? These are the two connectors, and here bigger one we have to call that as positive, and the smaller one negative. So this is cell. Okay, sometime we will call for a single cell as battery. That is wrong. So this is only cell. Then the second term, that is battery, and that big, small, there is one small gap, and it is connected to a bigger one, then small, and then it is connected to a bigger one, then small, and it will extend. Okay, so first one is, that is bigger one plus, then minus, plus, minus. So cell is a So cell is a single unit and battery is multiple units. So it is combination of cells. So battery means it is a combination of cells. So here single one cell, two cell, three cell. Three cells are connected and it forms a battery. Sometimes we can use many, 5 cells or 10 or plenty number of cells to form a battery. So it gives the or it gives the higher capacity. The next one, okay. So this is used to represent cell and this is symbol to represent the battery. The next one, the plug key. Third one, plug. Okay, this is a plug key, and in this case, so just concentrate on this diagram. So this is plug key, but this case is open. The next one is same, fourth one, plug key, but it is closed. But it is closed. So how to represent that? Same symbol, but in between we have to put one dot. In between we have to put one dot. So plug key open, so same, and for the plug key closed, that for that also same. But in the open, no need to put one dot here in the center, and in the plug key closed, we have to put one dot. So that is used to represent the plug key open and plug key closed. The next one is wire joint. The next one is wire joint. When 2 or 3 wires are joined. For example, this is one wire and this is another wire. So here these wires are joined at particular point. So therefore this is termed as wire joint. Or we can, in the textbook they gave 3. Okay. So we can consider this, or we can consider anything. Then after that, wire crossing without joint. So just look at this diagrams. So one is okay, cell, it is single unit, and a battery, it is combination of many cells, and plug key open, plug key closed, and wire joint. The next one, that is wire crossing without joining. Wire crossing without joint. So just now we draw this diagram. So these wires are joined at this point. But now we have to represent the two wires are crossing with each other, but they are not joined. So this is one wire, second wire, and here a small tilt is present. Okay. So first wire and second small tilt is present, that is used to represent these two wires are not joined. They are crossing with each other, but they are not joined. Just like we have bypass. So one underground path is there and one above path. They are not joining with each other. So similarly, so this is the symbol used to represent the wires are crossing, but they are without joining. The next one is electric bulb. Electric bulb. So that is why we say electric bulb. Next one is resistor. Resistor. So we have to draw zigzag here, and same length we have to consider in the upper part as well as in the lower part. So zigzag, that is used to represent resistor, and that comes in the later part, or that is also represented by using capital letter R, and it has also SI units and values, etc., etc. The next one is variable resistance. Manual variable resistors, but yeah, one arrow mark in it. So that represent variable. The resistance is not fixed. Here in this case, resistance is fixed. That value is fixed. But here we can change it. We can change that. Or that is by using also by using the symbol. This one. Okay. Or the next one is ammeter. Next one is ammeter. Or directly we'll use arrow mark here, plus minus ammeter. And the next one is voltmeter. Same symbol, plus minus. Next one is galvanometer. Yeah. So here three terms. One is ammeter, voltmeter, galvanometer. So ammeter work is, it is used to measure the current. Voltmeter it is used to measure the potential difference. Galvanometer means it is used to represent the flow of current, that means magnitude of current as well as direction of current. So ammeter and galvanometer work same, but there is a small difference. That is, ammeter shows only magnitude, but galvanometer shows magnitude as well as direction, and voltmeter represent the potential difference. Voltmeter represents the potential difference. So that means the ammeter represents the magnitude of current flowing, and voltmeter used to represent the potential difference, and galvanometer used to represent the magnitude of current as well as the direction of current. If you understood this, just click on the like button first. So these are the components we are used in the circuit diagrams. That is for the next to find out the different circuits, or to form the different circuits, we have to use this circuits components. Okay. So battery, cell, and resistor, variable resistor, or that is also called as rheostat, and ammeter, voltmeter, galvanometer, wire joint, plug key, closed, and many other parts we have to learn. Okay, and so based on this, we'll go to the next topic in the next class. Thank you everyone.